So Juno's a NASA spacecraft and project that's on its way to Jupiter. We launched in August of 2011, and we arrive at Jupiter on July 4th, 2016. Juno's primary science objective is to learn about Jupiter's origin. How was the planet made? How does that relate to how Earth and the other planets were made in our solar system? And in fact, how can we learn about how planets are made around other stars? So because Juno's a really big spacecraft, and it's pretty massive, and partly because we have to protect ourselves from a harsh environment at Jupiter, we have what's called a radiation vault. It's a box of titanium where the sensitive electronics are inside. But that adds a lot of mass, and so when we launched, we needed a big rocket, but even with a big rocket, we couldn't get enough speed to get all the way out to Jupiter. So we launched and we got all the way out to about the asteroid belt, and then the sun kind of pulls us back in because we're not going fast enough to reach Jupiter and get away from the sun completely. So what happens is we use what's called a gravity assist. We come back from the asteroid belt, come back toward the Earth, and we fly by the Earth, and we actually gain some momentum from the Earth. So we get that speed given to us, and that allows us to reach Jupiter. It takes us about 2 3/4 years after we fly by the Earth to get to Jupiter, and we're moving probably about 93,000 miles an hour. As Juno approaches the Earth on October 9th, we'll be coming from the sunlit side. We're coming from deep space. So Juno's going to get a perspective that's never been seen by humans. Earth from far away with the moon, Earth spinning on its axis. We're going to make a movie so we can all see what we look like from that deep space perspective. Sort of what do we look like if you were on Mars or Jupiter? So the prime objective of Juno is to learn about how Jupiter formed. We know that it's very similar to the Sun. It's almost all hydrogen and helium, just like the Sun is. But it has a smidgen more of what cosmologists call heavy elements. Those are everything heavier than helium. The carbon, the nitrogen, the sulfur, the noble gases. We don't know how that happened, but we know it's important because the stuff that Jupiter has a little more of than the Sun is what we are made out of.